Hello, I'm Glenn Darling from the Open Horizon team, and I'd like to give you a little bit of technical information about how workload networking works in Open Horizon. So the Open Horizon agent creates an individual Docker virtual private network between each producer-consumer pair of services in your application. By having a separate network for each service dependency relationship, the service access is strictly controlled. So, for example, the manufacturer can restrict access to hardware control services. Perhaps you have an actuator that turns a motor on or off or something like that, to only their own device management software. So only their own device management software can control the motor. While at the same time, they can allow third-party code to run on the same platform and access other components only and not that hardware device driver. So let's go through the basics of how this works. So normally you state dependencies between services when you create the service.definition.json file that describes the service when you go to publish the service. So in this case, service A has a stated dependency on service B, and that results in network number 1 being created. That rectangle there represents the network between service A and service B. And similarly, service B can go ahead and use another service by stating an explicit dependency on that other service, and a new network number 2 in the diagram, is created for that purpose. And similarly, you might have another application running on the same edge node where service D states a dependency on service E, and service E also has a dependency on service C. So both service B and service E are making use of service C. So maybe service C is something like an MQTT broker, and both of those services want to use it. Or maybe service C is providing some information about the host, a read-only service to look at the hardware perhaps, that any service is allowed to connect to. And of course you can have another completely independent service set of F, G, and H that are completely independent of those other services. Now, each one of those explicit dependencies means that communication in the direction of that dependency is allowed. But because these are just regular networks between them, virtual private networks between them, if we look at network number 3 in the middle of the screen there, you can also have service E use service D, even though service E has not stated a direct dependency on service D. It's just a normal network, so if service D can see service E, then service E can see service D as well. It's bidirectional. However, service D cannot connect to service C. It does not have a network connection to service C. So the containers in the environment of the container, service D has a NIC, or a network interface card, on network number 3. And service E has a network interface card, a simulated one, on network 3 and on network 4. So it can reach out through either one of those NICs to talk to service D or to talk to service C. But service D does not have a NIC on the network number 4, so it cannot reach service C. And it also doesn't have a NIC on network number 2, which can see service C. Similarly, service G way over there cannot reach service C, and perhaps surprisingly as well, service F cannot talk to service H. Even though it has an indirect dependency on service H, it doesn't have a direct one. And since it doesn't have a direct one, there's no network between them. Now let's look at a more detailed example so you can see actual connections that are possible and ones that are not. So here's a similar diagram to the last one. The green box on the left represents a container that is providing some kind of a service, and it's been given the alias name of PR. So when you create the service definition, you give the service a name, and that name is published to the virtual as the address on the virtual private network for anything that states a dependency on it. So the running consumer service, which is the green box on the right, if it wants to reach the providing service, it can just use the name PR. So it could do a command like curl PR, 7654 to reach port 7654 on that virtual private network. Now, the other boxes, let's talk about those. The large blue box represents the host that these two containers are running in. And the gray box that sits behind it represents the local area network on which that host is located. And I've got a small blue box at the bottom which represents another host on that local area network. Then the pink rounded rectangle represents the router, firewall, and modem that bridge that LAN out to the internet, that network that LAN out to the internet. And then the gray box on the right is the ISP's internet, and I've got a blue host there as well. That is just some random host out on the internet. So note that it's possible for the consumer workload process in the consumer service to also listen on a port. Note that the green arrow that sits above that is connecting to port 7654 on the provider service, but it's using an ephemeral port number on the running consumer service. But the consuming service could also be listening on a port, and then it's possible that other machines could talk to that port. Also, it's possible if you configure your service.definition.json, you can configure it to publish ports. And so you can choose which interfaces from the container get published to which interfaces from the host. And so in this case, just for simplicity, I'm publishing the same port number from the service onto the host for both of these processes. And I should also note that any of these containers, the provider service or the consumer service, are able to reach out to the internet through the firewall, through the LAN to the firewall, and out to the internet. So, the consumer workload process could do curl 169.200.200.200 and reach that internet host 169.200.200.200. Also, if you were to exec into the space of the running provider service, the PR service, you could use the localhost address to access the locally published 7654 port, which is on the NIC that is on the virtual network. And you could also reach out and communicate with the consumer service using its port 8765. This is like the example I showed previously of an undeclared dependency between these two services, but because they're on the same virtual network, they can both communicate to each other. Similarly, if you were to exec into the running consumer service, you'd be able to access the 8765 port that's on the NIC that's on the virtual network. And if you're on the host, if you have a shell on the host, then you are able to see all of the virtual networks on the host. There's a gateway enabling you to see these networks as well. So you could, as long as you know the IP address, the hard numeric IP address, you can't use the alias names PR and CO that I used here. But if you know the hard IP address of the NICs on those virtual networks, you can reach out to those particular port numbers from the host. And of course, from the host, you can reach any of the host ports because those are published on assuming they're published to the localhost interface on the host. And typically when you publish, you'll publish to 0.0.0.0 on the host, which will get to all of the host's NICs. So connection 6 and 7 would be done locally on the host to the host port 7654 or 8765. Whereas the other host shell that I showed there for connection number 4 and connection number 5, those are happening within the Docker virtual networks because the host has a NIC on the Docker virtual networks as well. Now, if there's another container running on the host, whether it's deployed by the Open Horizon agent or whether it's deployed manually, that container cannot see the Docker virtual network. So that the red arrow and the red X indicate that that container cannot reach that virtual network, so it cannot access port 7654 or 8765. It could, however, reach the host ports if you had published host ports, if it knew the IP address of the host. And that's something that would need to be passed into the container for it to discover that, or it would have to use more complicated techniques to get the address of the host. But once it's published to the host, it is exposed, and it would be possible in theory for that container to reach it as well. Now, if you are on another LAN host, you can access the host published ports for that host. And so the 7654 that got published to the local area network, and the 8765 that were published to the local area network, those network connections 8 and 9 on the diagram, those are possible. But that other LAN host would not be able to reach the Docker virtual network. And similarly, of course, any outside internet host cannot reach in to even access the host because of the firewall. So the takeaway that I hope you get from this is that exposing one of your ports to the host is adding risk. And generally, you don't want to do that unless you're providing a service that the host is offering to the internet, or at least to the host is offering to your LAN. And you could publish it to the internet if you did some port forwarding from your pink router firewall box over there. Now, at this point, I'd stop and ask for questions, but of course I can't answer them because you're watching a video. So if you have any questions, you'll have to reach out and contact me by email.